All right, these are the 4445 notes for congruent triangles. Today we're going to look at what CPCTC stands for and how to use it. So to begin with, CPCTC stands for corresponding parts of congruent triangles are congruent. And so what that means is that if you have a couple triangles, whatever the corresponding parts are to them, if they're congruent, will also be congruent. So you can get sides and angles congruent in that way. You just have to be able to match up letters. Okay. When we're doing this in a proof, we don't have to write out corresponding parts of congruent triangles are congruent. We can use CPCTC, and so that's the one easy part to it. So here we have a two-column proof. The one thing you want to always look for is what you're supposed to prove, because that's what has to go last in the proof. So HJ congruent to KL. And if this last thing is not a triangle that we're proving, then I know my reason is going to be CPCTC. Okay, there's only two different types of proofs. You're either going to have to prove triangles congruent or prove angles or sides using CPCTC. Since this is sides, we use CPCTC. Alright, so the first thing in our proofs that we should do is write down our givens. So angle H congruent to angle K, and angle 1 congruent to angle 4. Given and given. And then go ahead and mark those down. So we've got H to K and 1 and 4. Now in order to prove the CPCTC, we do need to have the triangles congruent. In order to prove a triangle, we need one of our ways, either angle, side, 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 angle, side. So given that we have two sides here on both of them, we're looking for either a side in between, which would be HJ and KL, or we can use this in between. Since we're trying to prove HJ and KL, we're not going to use those. And since this is a shared side, we can say that it's congruent to itself. So we will have LJ congruent to JL, and that's from the reflexive property, something we use a lot. And now we have angle, side, so that's going to be my reason for the triangle, and we just need to match up the correct letters. So if I start over here by angle 1, that would be J, and I'm going to go across the middle to L, and then up to H. So that is congruent to triangle. Once again, we got to start here where this angle was, matching with that one, so that would be L, going across to J, and down to K. So looking at these, and we'll just make this bigger here, so we've got triangle JLH, triangle LJK. So the corresponding parts here go along with the letters. So you have JL and LJ, or you'd have LH with JK, or even JH with LK. Those are the different corresponding parts that you could have. In this case, we're using the HJ and KL. Okay, alright. Next proof. Again, start with looking at what we need to prove. It's angles, so angle D congruent to angle B, which means CPCTC. And now we look at what we're given. Angle 1 congruent to angle 2, angle 3 congruent to angle 4. So 1 to 2, 3 and 4. Given, given. Once again, we've got two angles, so either proving the sides, which we don't have any information on, but once again we can use the reflexive property here, and since this is a mirrored image, we're going to go ahead and say CA congruent to CA. And we'll have our triangle. It looks like angle, side, angle here. And we just got to match up the letters. So we'll go C, triangle, CDA, this way. So that means I got to go this way. Congruent to triangle CBA. And that's it. Again, pattern, givens, CPCTC at the bottom. Okay, next proof here, we've got A is the midpoint of MT and SR. So what we're going to do is combine that into one given, since it's pretty much saying the same thing. So we'll say the midpoint of MT and SR given. And once again, here's our proof. M to T, not a triangle, so it must be CPCTC. Okay, so if A is a midpoint of MT, that means it breaks MT into two congruent parts. So that would give us AM congruent to AT. I do it the right direction there. And that would be the definition of a midpoint. Okay. And then same thing for SR, but we're going to use two dashes here, two tick marks, because we don't know if SA is congruent to MA or not, but we do know it's going to be congruent to RA. So SA congruent to RA for the same reason. So definition of a midpoint. And now again, to get to the triangles that we need, I've got two sides. So I need another side, which I don't have, or an angle. And the only angle that I can get is this center angle. So that would be angle MAS congruent to angle. So notice MA is along the one dash, so I'm going to have to use TA. So TAR. And the reason is they're vertical angles. And so now I have side angle side on my triangles. And I can actually use the exact same letter combination as the angle. So triangle MAS, TAR, and that was side angle side. Alright, here we have the last one that we're going to do. Once again, we're going to look at the fact that we have MA congruent to TA, and that is going to be CPCTC, because it's not a triangle. And we got to make some markings here. We have that MS is parallel, that's what those two lines mean, parallel to TR. So we can put a little arrow indicating that they are parallel, and that's given. And MS is congruent to TR. Given. Alright, so we can look and try to figure out the things that we have here. Okay, so one thing that I notice, again, we've got the lines crossing, so I'm going to have congruent angles right there because of the vertical angles. So I'll write in vertical angles so I don't forget. And now we need to list them. So we've got MAS, angle MAS is congruent to angle, and in this case it doesn't matter the orders so long as we are talking about this one, so angle TAR. Okay, so now we need to also get some other angles so that we can get the triangle, or sides. I don't see any information on sides, so we can't do that. We've got the vertical angles, and so what we're going to do here is use the fact that we have the parallel lines and look at it as this line being the transversal, which puts this angle and this angle congruent. Okay, because if we drew in these other lines for the parallel, I would have alternate interior angles. So we'll have angle SA, oh, no, not SA. All right. It is SMA congruent to angle RATA. And that's because alternate interior angles. And so now we have angle, we have angle, we have side angle angle, or angle angle side. So we can go ahead then and prove our triangles congruent. So actually, there's going to be one less step than we need here. So we've got triangle, we'll go AMS congruent to triangle ATR, and that is from angle angle side. And then we don't really need step 6 because we have it. We can go immediately to MA is congruent to TA for CPCTC. And that is the 4445 notes.